Good morning, grade 8. How are you today? Today, we are talking about chapter 7, lesson 8, geometric sequences. We will continue it now. Now, the geometric sequences. We say that we have two types of sequences, arithmetic and geometric. The arithmetic, it has a common difference, but the geometric, it has a common ratio that we said or we discussed about it in the previous lesson. Now, today we have first to remind what is a common ratio and what's the terms. We said that the sequence, it's not any list of numbers, it have to be ordered list of numbers, such as 3, 6, 18, 12, 24, and so on. These are, we call it a sequence. Now, and we said that this is a term. We name it with a sub 1 because this is a first term. This is a second term. We name it with a sub 2. This is a third term. We name it with a sub 3. And this is a fourth term. We name it with a sub 4. And also we say that if I'm talking about geometric, I'm talking about ratio. What does it mean by ratio? That's mean if I divide the second term into the first term, I get a number, we call it a ratio. And also, if I divide A3 by A2, we name it also by a ratio. And if they are equal, we call it a common ratio, so that this one I can call it a geometric sequence. Okay, now. So by that, if you are looking about the first, if you look at this one here, as you say, let's make a cross product. We will notice that A2 is equal A1, A sub 1 times R. Is it right? And if you're looking here also, you will say that A sub 3 is A sub 2 times R. So what does it mean here? Here, if I want to find the third term, I have to multiply R by the previous term, or the term that comes before it. That's mean A sub 3, I need A sub 2 times R. And also, if the same, if I say A sub 4, I need A sub 3 times R. I use, if I want to find A sub 4, I used the previous term times R. This one, that if I want to use the term or the term that comes before it, if I want to relate any term with the term that comes before it, we will say this one, we called it a recursive formula. So AR is A sub 3 times R, or A sub 3 is A sub 2 times R. This one, we called it. So this one, we called it a recursive formula. That if I want to find A sub 5 as an example, I will say this is A sub 4 times R. So its definition will be A sub n is A 4 raised to 5, it is n minus 1. I mean, if I want to find A sub 5, I will say it is A sub 4 times R. This will be now the recursive definition of the geometric sequence. A sub n is A sub n minus 1 times R. This is for the recursive formula. Let's have an example. Let's talk about the previous one. 3, 6, 12, 24, 48, and so on. To find the explicit formula, I just say that a sub n is a sub n minus 1 multiplied by r. What is the ratio now? Let's divide 6 by 3 is 2, and 12 by 6 it's it's 2 also. 24 by 12 it's also 2. So r now, what is the value of the common ratio r? It is 2. So this will be now our recursive formula. A sub n is a sub n minus 1 times 2. Now, let's talk about now the explicit formula. For the explicit formula, okay, here now, let's have the same example, 3, 6, 12, 24, 48, and so on. Here also, as we said, that we have a common ratio 2. Now, for this one here, if I want to find a second term, okay, what I have to do? I have to multiply the first term by r. Is it right? I have to multiply the first term, 3 times 2 equals 6, and 6 times 2 is equal to 12. So the second term is the first term times r. And the third term, how can I find the third term? But here, not related to the previous one, like the recursive, that if I want to find the third term, I have to go back to the second term. Here, no. I want you to find the third term, but related to the first term. How can I get 12 from 3? So related to the first term, I have to multiply 3. 3, I'll multiply it by 2. Then I'll multiply it by another 2. 3 times 2 times 2, I will get 12. So here, what did we say? Times 4 times r times r. Okay, let's find now the fourth term. I mean 24. If I want to find now the 24, what I have to do? I have now, let's see here, I want you now, if I want to find 24, I have using the first term. I have to multiply 3 times 2 times 2 times 2. So what does it mean? Can we summarize, or can we here conclude a formula? Let's see. Let's talk about a sub 4 as an example. It is a sub 1 times r raised to the power 3. And a sub 3 is r, is a1 times r raised to sub 2, r raised to 2. So what does it mean? That's mean if I want to find a sub n, I have to use the first term, as you see, times r. But what is the relation between 3 and 4? That if 4, if I subtract it from 1, I will get 3. So I will say it is n minus 1. Here I can say that a sub n is a sub 1 times r raised to the power n minus 1. As you see here, a sub 3 is a sub 1 times r squared, which is 3 minus 1. As an example, who can help me now to find a sub 100 as an example? A sub 100 is a1 times r raised to the power 100 minus 1. So a sub 100 is equal to a sub 1 times r raised to the power 99. As you see here, is it the same as exponential function that we said in the previous lessons, that the exponential functions is y equal a times b base b raised to the power x. So that, as I said, as I told you before, that the arithmetic sequence is the same as linear function, and the geometric sequence is as the same as the exponential function. Now, so by now, I can know the explicit and the recursive formula for the geometric sequence. Let's rewrite them now. The explicit and the recursive. The explicit is a sub n is a sub 1 times r to the power n minus 1. And the recursive is a sub n is a sub n minus 1 times r. This will be the explicit and the recursive formulas. Now, look at them. In the explicit formula, if I want to find any number of terms, what did I need? As an example, I want to find a sub 50. What did I need? I need r, the common ratio. I need the number of the term, and I need the first term. So if you know the first term, if you know the common ratio, if you know the number of the term, you can find the term. But in the recursive formula here, okay, if you want to find a sub 100, what did you need? You need r, it's okay, the common ratio, and you need also the a of sub 99. Is it seem to be difficult? Yes, because if I ask you about the explicit, it's very easy for me because I just need the first term and I will find any term you want to tell me about it. But if you ask me to find the recursive, it will be difficult or extremely difficult because if I need to a sub 100, I have to find a sub 99. But a sub 99, I didn't know it. I will go back to a sub 89 and a sub 87 and so on. Now, let's have now this example here. If you have this example as an 1, 2, 4, 8, 16, and so on. Let's name this one. This term was A1, this term was A2, this term was A3, A sub 4, A sub 5, A sub 6, A sub 7, A sub 8, and A sub 9. Now, if I want now from you to find A sub 9, okay, I want now to find A sub 9, but using the explicit formula. So let's find A sub 9 using the explicit formula. What does the explicit formula tell me? she said that a sub 1 times r to the power n minus 1. Now, so a sub 9, if I want to find it, I need a sub 1, which is 1, times r. Where's r? How can I find it? By dividing any two consecutive terms by each other. Like 4 divided by 2 is 2. So r here is equal to 2 times, what is n? It is 9 minus 1, 8. Now, 2 sub 8 is equal to what? Who can tell me? 2 raised to the power 8 is 236. So a sub 9 is 236. Is it easy now? Okay. This is how can I find a sub 9 using the explicit formula. But if I asked you now, use a sub 9, but not using the explicit, using the recursive, what you have to do? Let's see. Now, a sub 9 using now the recursive. Let's see now. For the recursive, a sub 9 is a sub 8 times 2, which is r. And it's okay. Did I have a sub 8? No. So I need to find a sub 8, which is a sub 7 times 2. Did I have now a sub 7? Also no. So I go back now to a sub 6. Sorry. To a sub 7. A sub 7 is a sub 6 times 2. Did I know now a sub 6? Also no. A sub 6 is a sub 5 times 2. So, did I have a sub 5 now? Yes, I have it. So, I will go back now one by one. What does it mean? I mean, a sub 5 is 16 times 2, it is 32. So, I will say that a sub 6 now is 32. But then, if I have now a sub 6, I can go now back here and multiply it by 2. So I will get a sub 7, which is 64. And if I have now a sub 7, I will multiply it by 2. So I will get 128, which is a sub 8. And then I will multiply a sub 8 times 2. I will get 256. So look here, I need a sub 9. I have to go back and find all of the previous or all the terms that's following before it. That can help me now to find a sub 9. So which one is easier for you? Yes, it would be the explicit. Why? Because for the explicit formula, I need only the first term to find any number of terms that I need. Now let's do got it 1. The previous got it that we talked about it in the previous lesson or in the previous class. Got it 1 now. Which of the following are geometric sequences? If the sequence is not geometric, is it arithmetic? Let's see now. Now here, Which of the following are geometric sequences? If the sequence is not geometric, is it arithmetic? Let's see number A. Oh, let's see number A, sorry. 3, 6, 12, 24, 48. Let's see it now. If I want to determine, if this sequence is arithmetic or geometric, I will find the ratio or a difference. This one and this one. I will try these two things. If the ratio now is common, I will say it is geometric. If it is not common, I will say it's not geometric. And also, if I have now a common difference, I will say it is arithmetic. And if it's not common, it's not the same, all of them is not the same, are not the same, it will be not arithmetic. So let's see here. Let's try now to find the difference. 6 minus 3 is 3. 12 minus 6 is 6. Are the ratios here, the differences here the same? No. So let's check the ratio. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 12 is 2. Are the ratios common, are equal? Yes. So I would say that this will be a geometric sequence. Let's see C now. One over 3, 1 over 9, 1 over 27, 1 over 81, and so on. Let's now find the ratio. So the ratio is 1 over 9 divided by 1 over 3. As you remember in grade 6, I want to divide fraction by fraction. It's like this. This one, it's mean 1 over 9 divided by 1 over 3. What did we say? We say that I will keep the first fraction as it is. Then I will change the divide to its opposite, which is multiply. Then I will write 1 over 3 as 3 over 1. Then after I simplify, I will get that the r here is 1 over 3. Let's take another one now. To be sure that this is a common ratio. It's not any ratio. Let's now divide let's divide 1 over 27 by 1 over 9. The first is it will be written like this. Then 1 over 27, keep it as 1 over 27. Divide, write it as multiply, and then 1 over 9. It will be 9 over 1. After simplifying, the answer is 1 over 3. So now, is the common, all the ratios here are common? Yes, look here, they are 1 over 3, 1 over 3, so they are common. So I will say it is geometric. Now here, as I told you before, any geometric sequence can be written with both an explicit and recursive formula. The recursive formula is useful for finding the next term in the sequence, and the explicit is more convenient when finding the nth term. The recursive, that's meant by it a sub n is a sub 1 and minus 1 times r, and the explicit, he mean by it by a sub n is a sub 1 times r and minus 1. Look at the first one. He told me it's useful to finding the next term, but the explicit formula is more convenient to finding the nth term. Now let's do problem number 2. Here now I have this sequence, this geometric sequence, and I want to find the explicit and also the recursive formula for it. Now, here I have 7, 7, 21, 63, 189. Okay, now for this one here, I just see it here now. Let's find the ratio. How can we find the ratio? Remind me, by dividing 21 into 7, which is 3. 63 into 21. 6 over 2 is let's multiply it by 3. 3 times 1 is 3. 3 times 2 is 6. So the answer is 3. And also 189 over 63 is 3. So the ratio R here is equal to 3. Okay. Then, then after that, now I want now to write the explicit. And also I want now to write the recursive. Now, for the explicit formula. What is the definition of it? Say that a sub n is a sub 1 times r raised to the power n minus 1. So, what do I need? I need r and I need a sub 1. What does it mean by a sub 1? It is the first term, which is 7. So, can I write it now? Yes. I will say that a sub n is a sub 1, which is 7, times r, which is 3. Then I will say that it is raised to the power n minus 1. This will be now a explicit formula. Now what about the recursive? The recursive is a sub n equal a sub n minus 1 times r. This is the recursive. So how can I write it now? I will say that a sub n is a sub n minus 1 are related to the previous term times r. What is r? Which is, which is 3. So now I will say that now a sub n will be a sub n minus 1 times 3. This will be an explicit and this will be an recursive. The explicit is a sub n equal a1. Where's a1? It is the first term, which is 7, times r, which is 3, raised to the power n minus 1. And a sub n, how can I find the recursive? if I want to find a sub n, I have to go back to the previous term, then multiply it by 3. Now, find the recursive and the explicit formulas for each of the following. We solve A, let's solve B now. For B now, we have 40, 20, 10, 5, and so on. So if I need to find now the recursive, what did I need? Or the explicit, the first thing I have to find it is the common ratio. Let's find now the common ratio, which is R, which it will be 20. Don't say 40 divided by 20. It is the second term divided by the first term. So it will be 20 over 40, which is half after you simplify it. So R here is 1 over 2, and 10 over 20 is half also, and 5 over 10 is half. So R now is equal 1 over 2. Now, so R here is half. And after that, I need now to write the explicit. How the explicit will be, the formula of it, who can remind me? It is A sub n equal A sub 1 times R raised to n minus 1. This is for the explicit. And the recursive will be A sub n is A sub 1 times R. A sub n minus 1 times R. Then after that, so this is an explicit, and this will be a recursive. By now, let's write now the recursive. Let's find now the explicit. For the explicit, I will say A sub n is A sub 1, which is the first term? It is 40 times what? Times R. Where's R? It is half. This half is raised, only half is raised to the power n minus 1. This will be an explicit formula. What about now the recursive? It is A sub n. It's equal to A sub n minus 1 times R. Where's R? Which is half. So this will be now an explicit and recursive formula for the geometric. Now, for this exercise here in your problem and practice and problem solving, I want you to determine whether the sequence is geometric sequence or arithmetic. Is it geometric? Let's see. The first one. Or no, here he wants to ask me if this is geometric or not. How can I know? by finding the ratio. If the ratio are common, it will be geometric. Let's see. 2, 8, 32, 128. Let's now divide each term by its previous one. 8 divided by 2 is 4. 32 divided by 8, it's 4 also. 128 divided by 32, if you divide it, you will find it's 4 also. Are the ratios the same? Are the ratios the same? Are they common? Yes. So since we have a common ratio, so I will say it will be a geometric sequence. What about number 11 now? Let's see number 11. We have 5, 10, 15, and 20. 10 divided by 5 is 2. 15 divided by 10. Let's divide it here. I just put a decimal point here, so it is 1.5. Are they the same? No. So they are not common ratio. So it's not. So I can say, sorry. So I can say, so this not a common. Sorry. This not will be. I'm so sorry. Here. So because of that, I'll say that it's not geometric sequence. Okay. Let's find now. Oh, let's go now to number 22. In number 22, he asked me now to find or to write an explicit formula for each geometric sequence. I want you now to solve number 25 and number 26. In number 25 here, as you see, you have 3, negative 12, 48, negative 198, and so on. So by now here, let's divide them. He told me it's geometric, so let's find the ratio. Why? Because if I want to find an explicit, I will remind you here, to find an explicit, I need a sub 1 times r and minus 1. A sub 1, the first term, it's written, so I need r. So let's find the ratio. How can I find the ratio in the geometric? By dividing the second term into the previous term. Negative 12 over 3 is negative over positive is negative, and 12 over 3 is 4. So the answer here is negative 4. Let's now divide 48 by 12. 48 by negative 12. Positive over negative is negative, and 48 over 12 is 4 also. So the ratio here is negative 4. Then I will say that the explicit formula will be A sub n is equal to A sub 1, which is 3, times, what is the value of r, as we said here, it is negative 4, raised to the power n minus 1. This will be an explicit formula for number 25. A sub n is 3 times negative 4 raised to the power n minus 1. Now let's find number 26 here now. In number 26, he also asked me to find or to write an explicit formula. And as we said before, an explicit formula is a sub n is a sub 1 times r raised to the power n minus 1. So I need a sub 1. Where's a sub 1 here? It is 8. And I need r. How can I find r? By dividing each term on the previous term. So let's divide now negative 8 into 8 to find r. Negative 8 into 8 is negative 1. Is it right? So what does it mean? So I mean here that negative 1 is a ratio. So can I write now the explicit formula? Yes, I can. I will say that a sub n is the first term, which is 8, times r, which is negative 1, and only negative 1 is raised to the power n minus 1. This is an explicit formula for a geometric sequence. I'm sorry, let's repeat it. Okay. Now, for this one here now, I want you now to write a recursive and the explicit also, and then I want you to find the eighth term of each sequence. Let's do A. In A here, okay, here I have A sub 1, 2, 3, 4. In A, let's solve A. In A here, I want to find now an A1. I know it is 14. And for R, it will be 84 divided by 14. Let's divide it here. And as I told you that if you want to divide, try to take the 10th number or recover the first number. And here you have 1. 8 over 1 is what? Is 8. But don't take 8. Take number that's less than 8. Let's try 7. 7 by 4 is 28. 7 times 1 is 7, plus 2 is 9. So it's not working. Let's take a number which is less than 7. Take now 6. 6 times 4, it is 24. 6 times 1 is 6, plus 2 is 84, so the answer is 6. So this is R now. So if I have A1 and if I have R, can I write the explicit formula? Yes. The explicit formula is A sub n is equal to A sub 1 times R raised to the power n minus 1. A sub 1, which is 14, R, it is 6, raised to the power n minus 1 is A sub n. Now using this explicit formula, can you find A sub 8? Yes, it's equal to 14 times 6 raised to the power 8 minus 1. So it is 14 times 6 raised to the power 7. Now 6 raised to the power 7 is 2, 6, using calculator, it is 2, 7, 9, 9, 3, 6. This number I will multiply it by 14, and the answer is 3, 9, 1, 9, 1, 0, 4. This will be a eighth term of the sequence A. Now, I want you now to find the recursive. Now, to find the recursive, I need times R, which is R, which is 6. So this will be an recursive formula. So I need, if I want to find now A sub 8, okay, he told me you have to find A sub 8 for both of them. If I want to find now A sub 8, so A sub 8 is A sub 7 times 6. Here what I have A sub 1, and I have A sub 2, and I have A sub 3, and I have A sub 4. So, oh my God, if I want to find A sub 8, I need A sub 7. And if I want to find A sub 7, I need A sub 6. And if I want to find A sub 6, sorry, I need to find A sub 5 times 6. And also, if I need A sub 5, I need to find A sub 4 times 6. But A sub 4 is given. So, if I want to find A sub 5, let's multiply 3024 by 6. Let's do it. Which is 18144. Then this number 18144, if you multiply it by 6, you will get A6. So you will get 108, sorry, 864. And this number, which is A6, if you multiply it also by 6, you will get 653184, which will be an 7th term. And finally, this term, if you multiply it by 6, you will get the previous number that we talked about it. No, it will be, sorry, it will be 3,919,104. It will be 3,919,104. This will be A sub 8. So actually, how the explicit formula is very easy for me and very more useful for me to find the any number of them. This will be our lesson. If you have any question, feel free to ask me. Thank you for listening.